Hello friend, how are you? I hope you are all will be fine. I'm also fine, thank you. Welcome to your channel. Today our lecture number 3 about Boron family. Today is lecture number 3 of Boron family. That is group 13, also called group 13 or third A. That is group 13. Today we will be in previous last two lectures. I already explained you the few general characteristic of boron family, but today I will be more characteristic. I will be explaining you further more characteristic of boron family. That is in first, that is the electropositive, or you can say that metallic character, electropositive character of boron family, or you can say that metallic character. So what about metallic character of boron family? What is the order of metallic character in the boron family as the metallic character increases or decreases along down the group? So let's start the topic, and please be concentrate on the topic. The elements of group 13 are less electropositive as compared to the alkali and alkaline earth metal. Alkali and alkaline earth metal. Alkali metal are the group first elements are alkali metal. Group first elements are alkali metal, by group second elements are alkaline earth metal. So as compared to alkali and alkaline earth metal, the group 13, or you can say that the third group element, that is the boron family, these elements are less electropositive as compared to the S block elements. These are both included in S blocks. Both of them are called S blocks. Both of them, alkali and alkaline earth metal, these two groups are called S blocks. So as compared to the third, the boron family, as compared to S blocks, these are less electropositive. What is the reason behind this? That why the boron family, why that the group third A is the less electropositive as compared to the electropositivity or metallic character as compared to the alkaline earth metal, or you can say that the as compared to S block, it will be the characters of metallic character in the boron family is lesser. So what is the reason behind this? The reason behind this is due to small size and ionization, a high ionization energy. Small size and high ionization, this is the first reason, and the second reason is a high ionization energy. Be remember, always remember that for high ionization energy mean that the atom or the elements of the that groups will require more energy, will require very high energy to ionize the system, to ionize the atoms. And we know that those atoms will be good metallic in character, that they can be easily ionized, that they can get easily positive charge. Those atom or those molecules that will be, those atom will have metallic character if they are high, if they are less ionized energy, means when you heat them, they will easily ionize. Means they will get plus positive charge, they will easily get positive. When the atoms get easily positive charge, when the atom get, that is in first group, that is lithium, sodium, potassium, cesium. So these are the first group elements, also called alkali metal. These are the first group elements, and these are second group elements, lithium, beryllium, magnesium, and so on. Also, that is the group third A elements. Third A elements are also called 13 group elements. That is boron, aluminium, gallium, indium, and thallium, and so on. So these are the less metallic character, less electropositive character as compared to the S block elements. These are S block elements. These are less electropositive. Why? Because we know that a long period from left to right in periodic table, when we move down from left to right in periodic table, atomic size decreases. So that's why the atomic size decreases, because electronegativity increases. Also the core electron are, you can say that the same number of shell electron are increased. That's why the nuclear force also increases in for the constant shell. That's why the atomic size reduces. So when the atomic size small size of the third groups also high ionization energy means that they cannot be easily ionizable. They cannot be easily getting positive charge, and we know that those metal will be good metallic in character when they get easily positive charge. But here in case of sodium, in case of magnesium, as compared to in case of sodium, which will be easily ionizable, their ionization energy will be very less as compared to magnesium, where magnesium ionization energy will be less as compared to aluminum. Means aluminum will have high ionization energy, so that's why aluminum will be get more energy to ionize, while sodium will be get less energy. So that's why sodium can be easily ionizable, and sodium will be good metallic in character. It will have more positive charge, it will have more plus charge, so that's why it will have more character, more metallic character, electropositive character. I hope the point will be cleared. While in this group from boron to thallium, in this group that is boron, aluminium, gallium, indium, and thallium. In this group from boron to the electropositive character increases from boron to aluminium. Electropositive character increases from boron to aluminium. After that, they decreases from aluminium to thallium. After that, decreases from aluminium to thallium. Here boron having very high ionization energy, because it contains non-metallic character, it is metallide, it contains non-metallic character, so that's why their high ionization energy is regarded as semi-metal, or you can say that it is metallide. This semi-metal at more closer to non-metal, at more closer to non-metal. Here boron is semi-metal due to high ionization energy at a semi-metal, and it is more closer to non-metal. These are the characteristics of boron. Aluminium is metal and electropositive. It is most electropositive. The increase in electropositive nature from boron to aluminium is due to the increase in atomic volume. Atomic volume increase, I already explained in first lecture, the atomic radius of the boron family. So atomic radius increases from boron to aluminium due to the remaining three elements, that is gallium, indium, and thallium. The first reason why the metallic character increases because the atomic size increases. I already told you here that from the left to right in periodic table, the atomic size decreases. That's why metallic character decreases from left to right in periodic table. So here from top to bottom in periodic table, atomic size increases. So that's why it should be increase the electropositive or metallic character. That's why the electropositive character increases from top to bottom in periodic table. That is boron, that is aluminum have more electropositive character as compared to boron. Also boron has semi-metal because of very high ionization energy, and it is more closer to the non-metal. While the increase in the remaining three elements, that is gallium, indium, and thallium, that is in between the aluminum, that is gallium, indium, and thallium, are less electropositive and less metallic than aluminum. And there is decrease from gallium to thallium in electropositive or metallic character. The reason behind this, the main basic reason is that the presence of D10 electron in the penultimate shell, D10 electron in the penultimate shell in gallium and in indium. In gallium and indium, inner D10 electron enter into the penultimate shell in case of gallium and indium, while in case of thallium, here is a D10 as well as a 14 electron inner shell of the thallium. So that's why they do not shield. I already explained in first lecture that it do not shield the D10 electron and F electron, it do not shield the nuclear charge effectively. So that's why their size will be reduced, little bit reduced, and it will show less electropositive character. So due to the reduce, or you can say that due to the less shielding effects of the nuclear charge on the outermost electron will be higher. That's why the electron cannot be easily removed in case of gallium, indium, and thallium. That's why their positive character or electropositive character or metallic character will be very less, will be decreased. And boron is bad conductor, while aluminum is good conductor of electricity. In case of boron family, boron is bad conductor, and boron is bad conductor, aluminum is good conductor of heat, while gallium, indium, thallium also conduct electricity but as compared to aluminum it is not too much very good conductor. I hope the points will be cleared of electropositive or metallic character. If you have any confusion, if you have any question, you can ask me in comment section. I will be replying. Now I'm cleaning the board to proceed the topic. You can take screenshot or you can rewind the video. Okay, thank you. So the next point is oxidation potential. Next general characteristic is oxidation potential. What is mean by oxidation potential? First of all, you should need that what is oxidation and what is reduction. So can you define what is oxidation? Please comment me. Define oxidation. So okay, now I'm telling you. Oxidation mean gain of oxygen or addition of oxygen. Gain of oxygen. Also oxidation mean loss of electron. Before the oxidation potential, you should need to remember these topics. Loss of electron. Also oxidation mean loss of hydrogen. This is the oxidation definition. Three definition. Reduction is against this. In definition of reduction, first of all, loss of oxygen. Second, gain of electron. It is completely against oxidation. Gain of electron, while gain of hydrogen or addition of hydrogen. So it is the against of oxidation. Oxidation and reduction are against to each other. So now come to the point. First of all, oxidation, definition of oxidation and reduction. Please remember this. It will be help in this point, and after that the coming point, that is oxidation state. So what is first of all, what is meant by oxidation potential? Oxidation potential, the potential for oxidation show a chemical electron or elements to be oxidized. You can define this oxidation potential. The potential for oxidation show a chemical element, by a chemical element to be oxidized. The potential for oxidation show by a chemical elements to be oxidized. This potential are called oxidation potential. Also oxidation potential means reducing nature, means they are reducing in nature because the oxidation potential. Boron doesn't in boron family, boron doesn't form positive charge in aqueous solution. Doesn't form positive charge in aqueous solution. And this low value of oxidation potential, it means when boron doesn't form positive charge, when boron doesn't form positive charge in aqueous solution, boron, because boron also belong from the metallide ion, also it is nearer to the non-metal, so that's why it doesn't get positive charge. It is very difficult for boron that it get positive charge. That's why the oxidation potential means that the elements should be oxidized, and we know that which elements will be oxidized. From the definition of oxidation, loss of electron means when the atom loss electron, they will be good oxidized, their oxidation potential will be very high. Oxidation potential directly depend upon, to this point, loss of electron. So here, in case of higher the loss of electron, higher will be oxidation potential. In case of boron in property, boron is nearer to the non-metal, so, and we know that the non-metal cannot lose electron easily, so that's why it will be, the oxidation potential of boron will be very less. The oxidation potential of boron will be very low. I hope my point will be clear. The oxidation potential values of other elements of the group are quite high. Oxidation potential values for other elements of the same groups, other elements of the groups are quite high, Why it quite high? Because these all are metal except boron in boron family, and we know that metals are good to loss of electron, so that's why their oxidation, and we know that the oxidation potential directly depend upon the loss of electron. So as the greater the loss of electron, their oxidation potential will be very high. So that's why the oxidation potential of the other elements of the groups other than boron in boron family will be very high, and this is due to the high heats. Also you can give the reason to this. This is due to the high heat of hydration on account of small size. There is also high heats. The second reason is why it is very high, because high heat of hydration of the other elements except then boron. High heat of hydration, what is meant by heat of hydration? Heat of hydration means when there is compound, when there is positive charge, that is, let's suppose this is the aluminium. After example you will be get clearly, that is the aluminium plus 3. Aluminium plus 3 will be very easily hydrated. Hydration means the addition of water. Addition of water in aqueous solution, water will be easily ionized this aluminium that will be ionized by water. That is water negative charge on this oxygen atom, partial negative charge. So from surrounding this will be solvated from everywhere, and this will become stabilized. So that's why addition of water hearing occur. Addition of water means is instead of, let's suppose here is aluminium Cl3 that is added with chlorine, 3 chlorine added. In case of aqueous solution, when you added aluminium chloride to water, to aqueous solution, it will generate into AlH2O taken 6 plus 3. This ion means chlorine are completely replaced by, because the heat of hydration means new bond. Also you should need that bond formation is an exothermic process. Bond formation is exothermic. Here is a high number of bond formed, and we know that the bond formation is exothermic process. Due to it is exothermic process, highly heat will be evolved, because of many bonds are formed in case of hydration process. So that's why aluminium, similarly gallium, indium, which have high positive charge, and so that's why they will have high heats of hydration. And those compounds that have high heats of hydration values, like that is AlCl3, that is in hydration in aqueous solution, it will generate, it will last very much heat, very much energy, and become stabilized more as compared to in case of AlCl3, H2O6. It will be more stabilized, more stable, it will be very less reactive in aqueous solution. So that's why it will lead to stability due to the loss of heat, high heat of hydration, means the high heat are evolved. So those solutions, those compounds, those ions that have high heat of hydration will be more stable, and those compounds that are those atoms that have, are those metal, are those ions that have high heat of hydration will also high heat of oxidation potential, because it have capacity to last, to remove high number of electron, and we know that the loss of electron is called oxidation potential, because more the oxidation of the elements, more will be the oxidation potential, and oxidation means loss of electron. I hope my point will be cleared. Also, aluminium is strong reducing agent. Aluminium is also strong reducing agent. Let's take the correct position of the camera. Yeah, aluminium is also strong reducing agent. What is meant by reducing agent? Reducing agent means it will be reduce another atom or another molecule. It will be cause of, reducing agent means cause of to another atom or to another compound reduction, means another, due to reducing agent, due to one substance, due to one molecule or one atom, that is reducing agent, due to this atom another compound will be occur in the reaction, another compound will be undergo reduction process, and we know that the reduction is the gain of electrons. So here, let's suppose here AlCl3, in case of AlCl3 also, reduction also means loss of oxygen. Reduction also means gain of hydrogen. So here it is strong reducing agents. Due to this, the another atom will be reduced. Al is strong reducing agent. Due to this, the another by itself reducing agent will be itself oxidized. By itself it will be oxidized, it will be lost electron, it will be donated electron to chlorine, while due to this reducing agent the another molecule will be reduced. So here in case of H2O donate water, it lost oxygen, to the Al. So that's why it will be reduced, and it gain electrons. From where it gain? From aluminium it will gain electrons. So that's why the another atom will be reduced. So we can say that the aluminium is also strong reducing agent, or you can say the reason to this point is the reason of this point is aluminium is a strong reducing agent because it has low ionization energy of aluminium. I hope my point will be cleared. If you have any confusion, you can drop comments. Now let's proceed the topic. To proceed the topic, I am just cleaning the board. You can take screenshot or you can rewind the video. Okay, thank you. You can rewind the video. Yeah, the another general characteristic of boron family is oxidation state. That is oxidation state. Oxidation state of boron family. Have you any idea about oxidation state of boron family? Okay, let's discuss. It is in group 13 that we first encounter elements passing more than one oxidation state. Like here in this group, in boron family, here is some cases. first case is more than one oxidation state present. More than one oxidation state usually present. More than one oxidation state. More than one oxidation state present. But after that point, you should remember that in case of boron family, the electronic configuration is ns2np1. np1. This is the electronic configuration of boron family or group 13 element, or the first group of the p blocks. You can say that. So this is according to this grouping is present in the outermost. It is outermost energy shell of the elements of the group 13 elements. It is the outermost shell of the group 13 elements. Or you can say that third of a group elements. The expected oxidation state are +3 and +1. The expected oxidation in this group, the expected oxidation state is either it will be +3 or it will be +1. Why it cannot be +2? Only +3 or +1. Either it will be in +3 oxidation state or in +1 oxidation state. Here NS2 is filled. It will be like this. That is NS2, where NS2 means here is 2 electron present. In case of P, NP, where is 1 electron present. So due to this, in this case, only one other elements can be bonded to this system. So that's why oxidation state will be +1, means 1 electron will be removed. Or you in another case, when the system excited, after the excitation of electronic configuration, it will be shifted like this. Here 1 electron, 1 electron, 1 electron, 1 electron move here. So that's why in this case the oxidation state means number of bonding will be 3 bond, can be 3 different atom can be attacked, like in case of AlCl3. Due to this due to this excitation, it formed 3 with 3 bonded. So that's why in this case AlCl3 +3 oxidation state. So here not +2 possible, only +3 or +1 oxidation state will be. So in this case, the expected oxidation state is +3 or +1. While boron show +3 oxidation state in all compounds, boron show +3 oxidation state in all compound. Show +3 oxidation state in all compound. Other members show +3 and +1 other than boron. That is boron, aluminium, gallium, indium, and thallium. These are the third group elements, or 13th group element. That is boron family. So here in this case boron contain only +3 in all cases. In all compound it should have +3 oxidation state. Other than boron, +1 and +3 oxidation state both are possible. Other than boron, other members show +3 and +1. Other members show +3 and +1 oxidation state. The stability of +1 oxidation state increases down the group 1. That is the down the group 1. So here thallium will be accommodate. Thallium will be happy that they have +1 oxidation state. Thallium will be happy when they have +1 oxidation state, as compared to an indium. From bottom to top, the +3 oxidation state will be increased, because boron have +3 oxidation state in all cases, while thallium have in all cases +1 oxidation state. Mostly it will have, because thallium will be more stable in +1 oxidation state as compared to in +3 oxidation state. Due to this, why oxidation state of +1 will be increases from top to bottom. +1 will be decreases from top to bottom. Means you can say that it will be increases. It will be more stable. Thallium will be in +3. Here boron, that is boron which have +3, it will be the stability order of boron. You can say the relative stability. Here you can write a stability order of stability order of +3 and +1 oxidation state. So +3 oxidation state boron will be, in case of +3 oxidation, boron will be more stable as compared to aluminum, which have in +3 state, which will be more stable in case of when gallium is +3 oxidation state, which will be more stable when indium have +3 oxidation state, which will be more stable in as compared to when thallium have +3 oxidation state. But as compared to in +1 oxidation state, thallium will be more stable in +1 oxidation. In +3 state, in +3, the stability order will be decreases from top to bottom, means the boron will be very stable in case of +3, while thallium will be very unstable in case of +3 oxidation state. While in case of +1 oxidation state, boron will be very less stable as compared to aluminum when aluminum have +1 oxidation state, while it will be less stable in case as compared to gallium when gallium have +1 oxidation state, and so on. And at first point, thallium will be more stable. It will be very stable in case of +1 oxidation state. So why thallium have, in case of the decreasing stability order of boron family, in this case our thallium have very less stable in as compared to +3 oxidation state. What is the reason behind this? The basic reason behind this, that is due to the inert pair effect. It is the cause of inert pair effect. So what is inert pair effects? I will be explaining this point. Inert pair effect is that effect. In first lecture I already told you that S electron and P electron, it will show very high shielding effect, while D electron will show less shielding effects. The shielding effect will be not properly, mean it will show less shielding effect, while F electron, it will be show very less shielding effect, very less shielding effect. So due to this reason, when F electron show very less shielding effects, mean the outermost electron, the NS electron, NS and NP electron, it will be more closer to the nucleus. The nuclear charge, the effective nuclear charge on S electron, it will be very stronger. When it will be very stronger as compared to F, in case of indium, in case of thallium, the F orbital are involved. In case of thallium, the penultimate orbital are F orbital, F shell is penultimate shell. So and we know that F shell show less shielding effects to the effective nuclear charge. So that's why effective nuclear charge on N, it will be greater. That's why the electron in S shell, it will be strongly held by nucleus. So that's why the excitation will be not easily occur in case of when the electron of S are strongly held. That's why this effect is called inert pair effect, and this show due to this +3 oxidation state will be very less, while +1 oxidation state will be more stable. Means the electron in P shell, it can be excited, it can be lost by the thallium, while the electron of S, it cannot be lost by the system, or it cannot be bonded to the system. So that's why thallium in +1 oxidation state, it will be stable, while in case of +3 oxidation, it will be unstable. Means due to inert pair effect, the stability order of +3 oxidation state decreases from top to bottom in the boron family. It is due to the inert pair effect. I hope the point will be cleared. Still, if you have any confusion, if you have any question regarding the lecture, you can ask me in comment section anytime. I will be reply. Also, you can contact me in my personal WhatsApp that I put in description box, my personal WhatsApp number. Okay, thank you. Let's proceed the topic. If you can take screenshot or you can rewind the video. Now I am clearing the board to proceed the topic. Okay, thank you. So the one point that I skipped, the inert pair effect, definition of inert pair effect. You can define inert pair effect in this way. inert pair effect, in shortcut inert IPE, inert pair effects. So here inert pair effect is the tendency of the two electrons. You can define inert pair effect in this way. The inert pair effect is the tendency of the two electrons in the outermost atomic s orbital to remain unshared in compounds of post-transition metal. Post-transition metal are those metals that are heavier elements in the groups. Are called post-transition metals, like that is stellium. So as a result, the inert pair of ns electrons remain more tightly held by nucleus, as I told you before, and can't participate in bond formation or participate less in bond formation. So you can define inert pair effect in this way. You can take screenshot or you can rewind the video. Now I'm proceeding the topic. Okay, thank you. Also, one point is missing. Gallium appears to show +2 oxidation state, in GaCl2. In case of GaCl2, gallium show +2 oxidation state. However, it is believed that this compound has the structure that is in case of gallium GaCl2, that is GaCl2. In this structure, gallium have which one is univalent and one is trivalent. This gallium have univalent that have one oxidation state, while this gallium have +3 oxidation state. So in case of one compound, one gallium, two gallium atoms are used. One gallium will have +3 oxidation state and one gallium will have +1 oxidation state. I hope point will be cleared. Okay, so let's proceed to the next point. Let's proceed the topic to the next point. That is the nature of bonding of boron family. Nature of bonding of boron family. Here, next topic is nature of that is the one general characteristic, nature of bonding of boron family. So the nature of bonding, now I am just telling some points. The following points suggest that bonding in the compounds of group 13 or boron family should be covalent. Means all the elements, or you can say that the elements of the boron family, all the compounds of the boron family will be covalent in nature. The bond between the compounds of the boron family will be covalent in nature. So now I am showing some points. Showing you some points here. These points will suggest that these bonding are covalent. First point is the small size of ion. Small size of ion. According to Fajan rule, small size are responsible for polarization. According to Fajan rule, I will be also making one video on Fajan rule. So according to Fajan rule, small size of ion will responsible for high polarization. This is the first point, which is also the property of boron family. In boron family, small size of ions, all the ions in boron family have small sizes. So according to Fajan rule, they all are responsible for polarization. The another point is the sum of the ionization energy is very high. The sum of the three ionization energy. Three ionization energy is very high. I will be explaining this point in this topic. The next point is the electronegativity values are higher, and thus Here the sum of the three ionization energy, when the compound that have the high ionization energy, it have also responsible for the nature of bonding should be covalent. I'll be explain this point later. The next point is the electronegativity values are higher. The electronegativity values are higher, and thus when reacting with other elements the difference is not large. Electronegativity are higher of these compounds as compared to the S block elements, so that is alkali and alkaline earth metals. So these are the few factors, these are three factors that are involved, that are the reason of the that are the reason that boron family form, the compounds of boron family forming covalent bonds. I will be explained bit by bit, one by one. So first of all, that is the boron family. It is boron, aluminium, gallium, indium, and thallium. This is the boron family. So first of all, now I am talking about boron. Boron is considerably very smaller size. It have very smaller size than other elements of the other members of the same groups. Its ionization potential is maximum. Ionization potential is very maximum. Ionization energy is maximum because size is very small. That's why electron from the outermost shell cannot be easily removed. It will need very high energy, which is called ionization energy. So that's why high ionization energy, due to high ionization energy and smaller size, the bonding will be covalent bonding. The high ionization energy and smaller size of the atom, it will lead to the bonding as covalent according to Fajan rule, which is the first point of Fajan rule. It should be lead to covalent bonding. Nature of covalent bond will be present when the size of when the ions have small size. It means that they have high polarizing power. So the sum of the three ionization energy is very high. Similarly, this is also the factor that is necessary for the polarization, for the covalency, and it is also present in the boron. Boron have high ionization energy, so that's why all the bonding in boron will be covalency. All the bond, it always be show covalency. So many simple compound of the other elements, that is Al and Gl, Al and Ga, that is aluminium trichloride and gallium trichloride, or you can say that aluminium chloride and gallium chloride, these are covalent when anhydrous, when the solution is anhydrous. The bonding between aluminium chloride and gallium chloride, these are covalent. These will be covalent when they are present in anhydrous. What is meant by anhydrous? Anhydrous means without water. Means they are not in aqueous solution. They are without water. Without water means you can also take mean from this point that they are in crystalline form or in solid form. But not without water, in anhydrous form, the bonding between aluminium chloride and gallium chloride will be covalent in nature. However, aluminium, gallium, indium, and thallium, these all metals ion in solution. These all metals form ion in solution. Aluminium, gallium, indium, these all metal form ion in solution. Ion in solution. In solution means where is water present, where is aqueous solution. In solution, these ions are present, formed ions, while in case of without water, aluminium and gallium, the compound of aluminium and gallium are covalent in nature. The change from covalent to ionic occurs because the ions are highly hydrated. Why? When aluminium chloride and gallium chloride, in case of anhydrous, they are covalent. They are covalent when they are in anhydrous. While as you can add the water, just you add the water, means to it produce ions. When they produce ion, it means that the covalency will change to ionic character. It will be changed to ionic. So what is the reason behind it? Why it changed into ion? The change from covalent to ionic because these ions are highly hydrated. I already also told you before this point, before the nature of bonding, that these atoms have high hydration energy. Ions are These ions are highly hydrated. Hydration energy, highly hydration energy. What is meant by hydration? I already explained you that the energy that is be released, that is evolved during the hydration process, during the addition of water. So as compared to AlCl3, the hydration energy of AlCl3, when you add the water to this combined, it release 5808 kilojoule per mole experimental energy. It release this enough amount of energy. This is also called, you can say that this is the hydration energy. This is the hydration energy. But the three electronegative, the ionization energy of aluminium, that is 3 in case of plus 3. Aluminium in case of plus 3, the ionization energy, the sum of all the ionization energy, it is also very high. That is plus 3 has 5137 kilojoule per mole. This is the ionization energy when when three electrons are removed from the aluminium. So in case of hydration energy exceed the sum of the three ionization energy. So that's why the aluminum chloride will be changed into ion because of high hydration energy. So the covalent character will be changed into ionic character. I hope my point will be cleared. I talked all of these about boron, aluminium, gallium, indium. So what about thallium? The monocovalent thallium compound is ionic. It is ionic compound. Thallium compounds are ionic. Thallium compound are ionic. Thallium compound are ionic. Monocovalency of thallium. Monocovalency of thallium is due to the increasing reluctance of ns electrons, that is to form bonds. As I explained before, that inert pair effects. Inert pair effect is greater in thallium. Also, it has very high charge. It has very large size. Thallium has very greater size. Such inertness of ns electron is observed when electrons are in fifth or high energy shell, and the removal doesn't form cation whose electron configuration is that of an inert gas. Like this is the atomic size of thallium is very high. It will be like this. Sorry for the disturbing the board. So here in this case, this is, let's suppose this is the ns electron, that is the np electron, this is the ns electron. Removal of ns electron is very difficult due to the inert pair effect, as I already told you, because it is strongly held by the nucleus. While the np electron, where is one electron present, the size is enough larger. Even when you remove this electron, it doesn't affect that the thallium will be ionized, because it will be like that. It will be show behavior, it will be show property like that, that the inert compound, that the inert gases, this is like the noble gases, so their electronic configuration will become inert. So that's why it will show covalency, because inertness show covalency. And this behavior is due to the inert pair effect. I hope my point will be cleared. Also, some compound, that is AlCl3, GAlCl3, BF3, and BCl3, BH3. These all compounds are mostly compounds of boron family, are electron deficient compounds. Mostly compounds of group third A are electron deficient compound. Electron deficient compound. Why electron deficient compound? Because it it have deficiency, because it have sectant of electron in outermost shell or in bonding it have 6 electron. That's why 2 electron are missing. So we can say that electron deficient molecules. Due to the electron deficient molecules, the compounds, most of the compounds of boron family are also called Lewis acid. Also called Lewis acid. And we know that that Lewis acid are those acids that can accept lone pair of electron, that can accept electron pair. And I already told you that boron family have the second in outermost shell, it has 6 electron, 2 electron are missing. That's why they can accept one lone pair of electron, which is the property of Lewis acids. I hope my point will be clear. And electron deficiency can be removed by 3 different ways. Now I will be explain you one by one, bit by bit. Now I am just cleaning the board. You can take screenshot or you can rewind the video to proceed the topic. I am cleaning the board. Okay, thank you. So the electron deficient compounds remove their electron deficiency by the following ways. Number first, that is back bonding. Number first, that is due to back bonding. Due to back bonding, electrons can be these deficient compound can be remove their electron deficiency. What is back bonding? Back bonding will be like this. Let's suppose this is the BF3 structure. BF3 structure. F, this is F. So here one vacant orbital of boron is present. So one vacant orbital of boron is present. So let's suppose this is the vacant orbital of boron. Due to this boron is deficient molecule. Due to this vacant orbital, here completely filled orbital of fluorine also present. Of each of fluorine is present, which have 2 electrons. This orbital have 2 electrons. So that's why these electron can be this atom will be back bond by resonance. By stabilizing, resonance will be stabilize the system. Due to back bonding present that is pi bonding. Back bonding is also called pi bonding. Back bonding is the result of pi bonding, or pi bonding is the result of back bonding, you can say. Okay, here is back bonding or pi bonding developed, and this bonding will be resonance stabilizer. The resonance will be like this. First of all, the double bond will be present in this if after that this will be shift here. It will be like this, that bromine double bond if so by resonance it will become stabilizer. These are the back bonding. Due to back bonding, the deficiency of the boron family compounds can be reduced. The another factor is coordination with Lewis base. What is it mean? Coordination bond will be generated. Coordination bond will be produced. Let's suppose this is the BF3, and we know that one vacant orbital is present in B. So when you add ammonia to the system, the lone pair of ammonia, the lone pair of nitrogen, it will be attack on this vacant orbital and produce H3N that have plus charge, that will due to loss of electron it will get plus charge. That is boron, and that is the coordinate covalent bond. Coordinate covalent bond is denoted by arrow. This is the fluorine. These are due to coordination number. It has also removed electron deficiency. The third one step is through which it can remove deficiency of electron, that is polymerization. Due to polymerization, like that is in case of AlCl3. Due to polymerization means when many monomers combine to get a large molecule, which is polymerization, which is called polymerization. Due to AlCl3 like this, Cl3, Cl3, Cl, Al, Cl, that is Cl. So these are the polymerization. Due to this polymerization, it can be remove their valence, their deficiency of electrons. So these are the three methods, that is polymerization, coordination bond, formation of coordination bond with Lewis base, and back bonding. Due to this, these electron deficient compound of group boron family remove their electron deficiency. I hope my point will be cleared. These are the general characteristics of the boron family. After that we will be explained, I will be in next class I will be take on abnormal behavior of boron, or you can say that the anomalous behavior of boron. After that the difference between comparison of boron and aluminum, that is some similarity between these two compound, boron and aluminum, these two atoms, and dissimilarities. So after that, so if you have any confusion, if you have any question about regarding today's lecture, you can ask me in comment section. Please drop your comments. Also, if you like my lecture, please comment me in comment section, as well as subscribe my channel. It make me feel happy that my students are supporting me. Please subscribe my channel and also share the video with your friends. So that's why your friend also take advantage from the lecture. And if you have any confusion, if you have personal matter, you can also ask me in comment section. Also you can ask me in my personal WhatsApp or Gmail that I put in description box. Okay, thank you very much. Very best of luck, my dear student. Okay, very best of luck.